We are the Gujarat Technological University. Since its inception over a decade ago, GTU has been empowering young and curating minds to realize their true potential. Over 4 lakh inspired students are enrolled with one of the premier academic universities in India. With more than 450 affiliated colleges in its fold operating across 5 zones of the state, GTU, the International Innovative University, your place to move forward.
In this video lecture, we will discuss about the basics of state estimation in power system. First of all, when we hear this word state estimation, first question comes in our mind that what is state and what is estimation? So, the state estimation is the process of removing noise from the measurement. Normally, in power system, we are measuring different parameters like real power of transmission line, reactive power of transmission line, real power injection of bus, reactive power injection of buses, voltage magnitudes, current flows, phase angles. All these are the states in the power system. These are called as the state variables of the power system. Now, if we discuss about the problems in power system, the problem is the monitoring of the power flows and voltage on transmission system is very important in maintaining the system security. By simply checking each measured value against its limit, the power system operators can tell where problem exists in the transmission system. It is hoped they can take corrective action to relieve overload lines or out of limit voltage. There are many another problems. One is encountered in monitoring a transmission system. These problems come primarily from the nature of the measurement transducers and from communicating problems in transmitting the measured value back to the operations control center. Now, the transducer from power system measurement, like any measurement device, will be subjected to error. If the errors are small, they may go undetected and can cause misinterpretation by those reading the measured value. In addition, transducer may have some gross measurement errors. This render their output useless. So, the estimator is designed to produce the best estimate of the system voltage and phase angles, recognizing that there are errors in the measured quantities and that there may be redundant measurements. The output data from the state estimator that are used in system control centers in the implementation of the security constraint, dispatch and control of the system. Now, on the next, we will see the techniques which are used in power system for state estimation. The most popular estimate is used in power system is maximum likelihood weighted least square estimation. There are many another methods like least square estimation, maximum weighted least square estimation. So, if we will discuss about the basic points of this weighted least square estimation method with the concept of maximum likelihood. Now, the development of the notations in state estimation may proceed along several lines depending upon the different criteria selection. Here there are many criteria that have been examined and used in various applications which are following. The first criteria which is used in weighted least square estimation method is the maximum likelihood criteria. In this maximum likelihood criteria, the objective is to maximize the probability. The probability that the estimate of the state variable x bar is the true value of the state variable vector x. The second one is the weighted least square criteria, in which the objective is to minimize the sum of the square of the weighted deviations of the estimated measurements z bar from the actual measurement z. And the third one is the minimum variance criteria, in which the subject is to minimize the expected value of the sum of the squares of the deviations of the estimated components of the state variable vector from the corresponding components of the true state variable vector. Normally in power system, the maximum weighted least square estimation method is when in the maximum likelihood procedure ask the following question, like what is the probability that I will get the measurement I have obtained. This probability depends on the random errors in the measuring device as well as the unknown parameters to be estimated. Therefore, a reasonable procedure would be one that simply choose the estimate as the value that maximizes this probability. In the next lecture, we will discuss about the PDF, which is the probability density function, and how to use weighted least square estimation method in power system by taking some examples of load flow. Okay, thank you.